The space race was a pivotal moment in human history, sparking unprecedented innovation and global cooperation. As nations competed to reach the cosmos, they accelerated technological advancements that transformed our daily lives. The boundaries of human potential were forever expanded in this extraordinary era, and its legacy continues to propel us towards the stars. In the aftermath of World War II, the world was left to grapple with the devastating consequences of conflict and the looming specter of the Cold War. The United States and the Soviet Union, two superpowers emerging from the rubble, found themselves locked in a struggle for ideological supremacy. It was amidst this tense backdrop that the seeds of the space race were sown. The year was 1945, and the world was on the cusp of a new era of scientific discovery and technological innovation. In the Soviet Union, a young engineer named Sergei Korolev was already dreaming of the possibilities that space exploration held. Born in 1907 in the Ukrainian city of Zhytomyr, Korolev had grown up with a passion for mathematics and physics, eventually earning a degree in aeronautical engineering from the Moscow Higher Technical School. His early work on rocket design and development had caught the attention of the Soviet military, which saw the potential for these new technologies to be used in ballistic missiles. Meanwhile, in the United States, a similar story was unfolding. Robert Goddard, a physicist from Worcester, Massachusetts, had been experimenting with liquid-fueled rockets since the 1920s. His work, though often met with skepticism and even ridicule, had laid the foundation for the development of modern rocketry. On March 16, 1926, Goddard successfully launched the first liquid-fueled rocket from a farm in Auburn, Massachusetts, reaching an altitude of 41 feet and paving the way for future generations of rocket scientists. As the 1940s drew to a close, both the United States and the Soviet Union began to recognize the strategic importance of rocket technology. The Soviets, under the guidance of Korolev, established a secret research facility at Kapustin Yar, where they began developing the R-7 missile, a vehicle that would eventually become the backbone of their space program. In the United States, the Army Ballistic Missile Agency, ABMA, was formed, with Wernher von Braun, a German-born engineer who had worked on the V-2 rocket program during World War II, at its helm. The early 1950s saw a flurry of activity on both sides of the Iron Curtain. In 1951, the Soviet Union launched its first intercontinental ballistic missile, the R-7, which was capable of delivering a nuclear warhead to targets thousands of miles away. The United States responded with the development of its own ICBM program, with von Braun's team at ABMA working tirelessly to create a rival system. It was against this backdrop of intense military competition that the idea of space exploration began to take hold. In 1952, the International Council of Scientific Unions, ICSU, proposed the establishment of an International Geophysical Year, IGY, a global scientific effort aimed at studying the Earth's physical environment. The IGY, scheduled to take place from July 1957 to December 1958, would provide a unique opportunity for scientists from around the world to collaborate on a range of projects, including the launch of artificial satellites into orbit. As the International Geophysical Year, IGY, approached, the scientific community was abuzz with excitement. The prospect of launching artificial satellites into orbit had sparked a flurry of activity on both sides of the Iron Curtain. In the Soviet Union, Sergei Korolev's team at OKB-1, the secret research facility at Kapustin Yar, was working tirelessly to develop a launch vehicle capable of carrying a satellite into space. The R-7 missile, which had been successfully tested as an intercontinental ballistic missile, was seen as the ideal candidate for this task. Meanwhile, in the United States, the National Advisory Committee for Aeronautics, NACAA, had established a special committee to oversee the development of an American satellite program. The committee, chaired by Hugh Dryden, a renowned physicist and engineer, had selected a team led by Wernher von Braun at ABMA to develop a launch vehicle based on the Jupiter C rocket. The Jupiter C, which was essentially a modified Redstone rocket with a cluster of solid-fueled rockets attached to its base, was seen as a reliable and efficient way to launch a small satellite into orbit. As the IGY commenced in July 1957, the world was poised on the brink of a major breakthrough. On October 4, 1957, Korolev's team successfully launched Sputnik 1, the world's first artificial satellite, into orbit around the Earth. The small, beach ball-sized satellite, which weighed approximately 83 kilograms, was equipped with a simple radio transmitter that beeped out a signal at a frequency of 20.005 megahertz. The launch of Sputnik 1 sent shockwaves around the world as people from all walks of life gathered to listen to the satellite's signals and marvel at the achievement. The American response was swift and decisive. On November 8, 1957, the United States launched its first attempt at an artificial satellite known as Vanguard TV-1, but it ended in failure when the rocket exploded on the launch pad. The setback was a major blow to American prestige, and it highlighted the significant lead that the Soviet Union had established in the space race. However, the Americans were not deterred, and they continued to work tirelessly towards launching their own satellite into orbit. The next few months saw a series of intense activities on both sides, as scientists and engineers worked around the clock to develop new launch vehicles, satellites, and spacecraft. The world was witnessing an unprecedented era of technological innovation, driven by the Cold War rivalry between two superpowers. In the Soviet Union, Korolev's team was already working on their next project, a satellite that would carry a living creature into space. The launch of Laika, a small stray dog from Moscow, was scheduled for November 3, 1957, aboard the Sputnik 2 spacecraft. Laika, who had been chosen for her small size and calm temperament, was to become the first living being to orbit the Earth. The mission was a major undertaking, requiring significant advances in life support systems, temperature control, and radiation protection. As the launch date approached, Korolev's team worked tirelessly to ensure that everything was in place for a successful mission. The Sputnik 2 spacecraft, which weighed approximately 508 kilograms, 1,120 pounds, was equipped with a sophisticated life support system, including oxygen generators, temperature control units, and a special compartment to house Laika. The launch vehicle, an R-7 rocket, had been modified to carry the heavier payload, and the launch site at Baikonur had been prepared for the historic event. As the Sputnik 2 spacecraft soared into the sky on November 3, 1957, Laika became an instant sensation, captivating the hearts of people around the world. The mission was a groundbreaking achievement, marking the first time a living creature had been launched into orbit. Although Laika did not survive the flight due to overheating and stress, her sacrifice paved the way for future human spaceflight. The success of Sputnik 2 demonstrated the Soviet Union's capabilities in space exploration, further solidifying their lead in the space race. In response to the Soviet Union's achievements, the United States intensified its efforts to launch a successful satellite. On January 31, 1958, the Americans finally succeeded with the launch of Explorer 1, designed and built by a team led by Wernher von Braun at the Army Ballistic Missile Agency, ABMA. The satellite, weighing approximately 13 kilograms, was carried into space by a Jupiter C rocket and discovered the Van Allen radiation belt, a region of intense radiation surrounding the Earth. This discovery revolutionized our understanding of the Earth's magnetic field and its interaction with the solar wind. As the space race heated up, both nations continued to push the boundaries of space exploration. On March 5, 1958, the Soviet Union launched Sputnik 3, a more advanced satellite equipped with a suite of scientific instruments, including a radiation detector, a cosmic ray counter, and a micrometeoroid detector. The satellite weighed approximately 1,327 kilograms and provided valuable data on the Earth's magnetic field, radiation belts, and upper atmosphere. Meanwhile, the United States was making rapid progress in its own space program. On April 14, 1958, the Americans launched the Vanguard TV-5 satellite, which successfully reached orbit and transmitted valuable data on the Earth's atmosphere and magnetic field. Although the satellite weighed only about 10 kilograms, it marked an important milestone in the development of American space capabilities. As the year drew to a close, both nations were preparing for even more ambitious missions. The Soviet Union was working on a new spacecraft designed to carry a human into space, while the United States was developing a series of advanced satellites and launch vehicles. In the midst of this intense competition, a new player emerged on the scene: NASA, the National Aeronautics and Space Administration. Established on July 29, 1958, NASA was created to consolidate America's space efforts under a single umbrella organization. With a budget of $100 million and a mandate to explore space and aeronautics, NASA was poised to play a leading role in the space race. As the agency began to take shape, its leaders, including Administrator T. Keith Glennon and Deputy Administrator Robert C. Seamans, set their sights on an ambitious goal: landing a human on the moon within a decade. As NASA began to take shape, its leaders faced the daunting task of consolidating America's disparate space efforts into a cohesive program. The agency's first administrator, T. Keith Glennon, worked closely with Deputy Administrator Robert C. Seamans to establish a clear vision and strategy for the nation's space exploration endeavors. One of their earliest decisions was to create a new office, the Office of Spaceflight Programs, which would be responsible for overseeing the development of manned spacecraft and launch vehicles. In October 1958, NASA announced its first major program, Project Mercury, aimed at sending a human into space and returning them safely to Earth. The project was led by Robert Gilruth, a veteran engineer and manager who had previously worked on the Navajo missile program at the National Advisory Committee for Aeronautics, NACA. Gilruth's team faced numerous challenges, including designing a reliable launch vehicle, developing a heat shield to protect the spacecraft during re-entry, and creating a sophisticated life support system. Meanwhile, the Soviet Union continued to push the boundaries of space exploration. On January 2, 1959, the Soviets launched Luna-1, an unmanned spacecraft that became the first human-made object to escape Earth's gravity and fly by the moon. The mission was a major success, providing valuable data on the moon's composition, magnetic field, and radiation environment. The Soviet Union followed up this achievement with the launch of Luna-2 on September 12, 1959, which became the first spacecraft to impact the moon's surface. As the space race intensified, NASA's Project Mercury gained momentum. In November 1959, the agency announced its selection of the first 7 astronauts, who would undergo rigorous training to prepare for the challenges of spaceflight. The Mercury 7, as they came to be known, included Alan Shepard, Gus Grissom, John Glenn, Scott Carpenter, Wally Schirra, Gordon Cooper, and Deke Slayton. These brave individuals would soon become household names as they embarked on a series of historic missions that would take them to the edge of space and beyond. In the spring of 1960, NASA's Marshall Space Flight Center, led by Director Wernher von Braun, began developing the Saturn I launch vehicle, which would eventually become the backbone of the American space program. The Saturn I was a massive rocket, standing over 180 feet tall and weighing more than 1 million pounds. Its development required significant advances in materials, science, propulsion systems, and guidance technology. As the summer of 1960 approached, the Soviet Union prepared to launch its next major spacecraft, Vostok 1, which would carry a human into space for the first time. The mission was led by chief designer Sergei Korolev, who had masterminded many of the Soviet Union's most successful space missions. Korolev's team faced numerous challenges, including developing a reliable launch vehicle, creating a pressurized spacecraft cabin, and designing a sophisticated life support system. On April 12, 1961, Soviet cosmonaut Yuri Gagarin became the first human to journey into outer space aboard the Vostok 1 spacecraft. The mission was a groundbreaking achievement, with Gagarin completing 1 orbit of the Earth in 108 minutes. The success of Vostok 1 marked a significant milestone in the space race, as it demonstrated the Soviet Union's capability to launch a human into space and return them safely to Earth. As news of Gagarin's historic flight spread, NASA's Project Mercury team redoubled their efforts to prepare for America's first manned spaceflight. On May 5, 1961, astronaut Alan Shepard became the first American in space aboard the Freedom 7 spacecraft. The suborbital flight lasted just over 15 minutes, with Shepard reaching an altitude of 102 miles and a maximum speed of 4,200 miles per hour. The success of Freedom 7 was followed by the launch of Gus Grissom's Liberty Bell 7 spacecraft on July 21, 1961. The mission was also a suborbital flight, but it ended in drama when the spacecraft's hatch blew open prematurely, causing water to flood the capsule and nearly drowning Grissom. The incident highlighted the risks and challenges of space travel, but it also demonstrated the resilience and determination of the astronauts and their support teams. As the summer of 1961 drew to a close, NASA's Project Mercury team began preparing for their first orbital flight. On February 20, 1962, astronaut John Glenn became the first American to orbit the Earth aboard the Friendship 7 spacecraft. The mission lasted just over 5 hours, with Glenn completing 3 orbits of the planet and reaching a maximum altitude of 162 miles. The success of Friendship 7 marked a major turning point in the space race, as it demonstrated America's capability to launch a human into orbit and return them safely to Earth. The mission also marked a significant milestone in the development of NASA's spaceflight capabilities, as it paved the way for future manned missions to the Moon and beyond. In the months that followed, NASA's Project Mercury team continued to push the boundaries of space exploration, with astronauts Scott Carpenter, Wally Schirra, and Gordon Cooper completing increasingly complex orbital flights. The Soviet Union also continued to achieve significant milestones, including the launch of the Vostok 3 and Vostok 4 spacecraft in August 1962, which carried cosmonauts Andrian Nikolaev and Pavel Popovich into space for nearly 4 days. As the space race intensified, NASA's leaders began to look beyond the Mercury program towards more ambitious goals, such as landing a human on the Moon. In September 1962, NASA Administrator James Webb announced plans for the Gemini program, which would focus on developing the capabilities needed for a lunar mission, including rendezvous and docking in space and extravehicular activity. The Gemini program was led by Charles Matthews, a veteran NASA manager who had previously worked on the Mercury program. Matthews' team faced numerous challenges, including designing a new spacecraft that could carry 2 astronauts into orbit and developing the systems needed for rendezvous and docking in space. The success of the Gemini program would be crucial to the ultimate goal of landing a human on the Moon, and NASA's leaders were determined to push the boundaries of space exploration as quickly and safely as possible. As the Gemini program began to take shape, NASA's engineers and technicians worked tirelessly to develop the necessary hardware and systems. One of the key challenges was designing a spacecraft that could carry 2 astronauts into orbit and provide them with the necessary life support systems for extended periods. The Gemini spacecraft was designed to be more advanced than its Mercury predecessor, with a larger cabin, improved temperature control, and enhanced communication equipment. In January 1963, NASA announced the selection of the first group of astronauts who would fly on the Gemini missions. This group included Gus Grissom, John Young, Wally Schirra, and Frank Borman, among others. These astronauts underwent rigorous training to prepare them for the demands of spaceflight, including weightlessness, high G-forces, and emergency procedures. Meanwhile, the Soviet Union continued to make strides in its own space program. In June 1963, cosmonaut Valentina Tereshkova became the first woman to journey into outer space aboard the Vostok 6 spacecraft. Her mission lasted almost 3 days, during which she completed 48 orbits of the Earth and spent more than 71 hours in space. The success of Tereshkova's mission marked a significant milestone for the Soviet Union, demonstrating its capability to launch a woman into space and return her safely to Earth. As the Gemini program progressed, NASA's engineers encountered numerous technical challenges. One of the most significant hurdles was developing a reliable rendezvous and docking system, which would allow 2 spacecraft to meet in orbit and dock together. This capability was crucial for future lunar missions, as it would enable astronauts to transfer from one spacecraft to another in orbit around the Moon. In October 1963, NASA conducted an unmanned test flight of the Gemini spacecraft, designated Gemini 1. The mission was designed to test the structural integrity of the spacecraft and its systems, as well as the launch vehicle that would carry it into orbit. Although the mission was successful, it revealed several technical issues that needed to be addressed before the first manned Gemini flight could take place. In the months that followed, NASA's engineers worked to resolve these technical challenges, conducting a series of unmanned test flights and ground tests to validate the design of the Gemini spacecraft and its systems. Meanwhile, the astronauts selected for the Gemini program continued their training, preparing themselves for the demands of spaceflight and the complex tasks they would perform in orbit. On April 8, 1964, NASA launched the first manned Gemini mission, Gemini 1's successor, Gemini 3, but it was actually an unmanned test flight. However, the first crewed mission was Gemini 3's successor, Gemini 4's predecessor, Gemini 3. However, the first actual crewed mission of the program was crewed by Gus Grissom and John Young aboard Gemini 3 on March 23, 1965. Their mission lasted for almost 5 hours, during which they completed 3 orbits of the Earth. The success of Gemini 3 marked an important milestone in the development of NASA's spaceflight capabilities, demonstrating the agency's ability to launch a 2-person crew into orbit and return them safely to Earth. The mission also paved the way for future Gemini flights, which would push the boundaries of space exploration even further, testing the limits of human endurance and the capabilities of the spacecraft and its systems. On June 3, 1965, NASA launched Gemini 4, crewed by James McDivitt and Ed White. During their 4-day mission, the astronauts completed 66 orbits of the Earth and conducted a series of scientific experiments, including the first American spacewalk, performed by Ed White. The success of Gemini 4 marked another significant milestone in the development of NASA's spaceflight capabilities, demonstrating the agency's ability to conduct complex operations in orbit and paving the way for future manned missions. As the Gemini program continued to progress, NASA's engineers and astronauts encountered new challenges and opportunities. The next mission, Gemini 5, crewed by Gordon Cooper and Pete Conrad, was launched on August 21, 1965, and lasted for almost 8 days, during which the astronauts completed 120 orbits of the Earth and conducted a series of scientific experiments. The mission also highlighted the importance of teamwork and communication between astronauts and ground controllers, as well as the need for reliable systems and backup procedures in case of emergencies. As the Gemini program drew to a close, NASA's engineers and astronauts began to focus on the next phase of space exploration, landing a human on the Moon. The agency's new program, Apollo, would require significant advances in technology and capability, including the development of a powerful new rocket, the Saturn V, and a lunar module that could carry astronauts to the Moon's surface. In December 1965, NASA launched Gemini 7, crewed by Frank Borman and Jim Lovell, which was followed by Gemini 6A, crewed by Wally Schirra and Tom Stafford. The 2 spacecraft rendezvoused in orbit, demonstrating the capability to dock 2 spacecraft together, a crucial step towards landing on the Moon. In January 1966, NASA launched Gemini 8, crewed by Neil Armstrong and David Scott, which tested the rendezvous and docking capabilities of the Gemini spacecraft with an unmanned target vehicle. Although the mission was cut short due to a stuck thruster, it provided valuable experience for the astronauts and engineers who would go on to work on the Apollo program. In March 1966, NASA launched Gemini 9, crewed by Tom Stafford and Gene Cernan, which tested the new augmented target docking adapter and conducted 2 extravehicular activities. The mission marked an important milestone in the development of spacewalking capabilities, with Cernan spending over 2 hours outside the spacecraft. Meanwhile, NASA's Apollo program was gaining momentum, with the first unmanned test flight of the Saturn 1B rocket, AS-201, launched on February 26, 1966. The successful test demonstrated the capability of the Saturn 1B to carry a payload into orbit and pave the way for future manned missions. As the Gemini program came to a close, NASA's astronauts began to transition to the Apollo program, with many of them undergoing training for the lunar missions. In June 1966, NASA launched Gemini 10, crewed by John Young and Michael Collins, which conducted a series of rendezvous and docking maneuvers with 2 unmanned target vehicles. The mission marked an important milestone in the development of orbital rendezvous capabilities and provided valuable experience for the astronauts who would go on to fly on the Apollo missions. In July 1966, NASA launched Gemini 11, crewed by Pete Conrad and Richard Gordon, which tested the new tethering system and conducted a series of scientific experiments. The mission marked an important milestone in the development of spacewalking capabilities, with Gordon spending over 2 hours outside the spacecraft. Meanwhile, NASA's Apollo program was making rapid progress, with the first manned test flight of the Saturn IB rocket, AS-204, scheduled for early 1967. In September 1966, NASA launched Gemini 12, crewed by Jim Lovell and Edwin Buzz Aldrin, which conducted a series of rendezvous and docking maneuvers with an unmanned target vehicle. As the Gemini program came to a close, NASA's engineers and astronauts had gained a wealth of experience and knowledge that would be crucial to the success of the Apollo program. In October 1966, NASA announced the crew assignments for the first manned Apollo mission, AS-204, which would be commanded by Gus Grissom and crewed by Ed White and Roger Chaffee. The mission was scheduled to launch in February 1967 and would test the capabilities of the command and service module in Earth orbit. Meanwhile, NASA's engineers were working tirelessly to develop the lunar module, which would carry astronauts to the moon's surface on future Apollo missions. On January 27, 1967, a tragic accident occurred during a ground test of the Apollo Command and Service Module, AS-204, at Kennedy Space Center's Launch Complex 34. A fire broke out in the command module, killing all 3 crew members, Gus Grissom, Ed White, and Roger Chaffee. The incident was a devastating setback for the Apollo program, and it led to a thorough investigation and significant changes to the spacecraft's design and safety procedures. Despite this tragedy, NASA persevered and continued to work towards its goal of landing a man on the moon. In April 1967, the agency announced that the first manned Apollo mission would be Apollo 7, which would be crewed by Wally Schirra, Don Fulton Eisel, and Walter Cunningham. On October 9, 1967, NASA launched an uncrewed Apollo test flight, Apollo 4, which successfully tested the Saturn V rocket's performance in space. This was followed by another uncrewed test flight, Apollo 6, on April 4, 1968, which also demonstrated the Saturn V's capabilities. In October 1968, NASA launched Apollo 7, the first manned Apollo mission, crewed by Wally Schirra, Don Eisel, and Walter Cunningham. The mission was a success, with the crew spending 10 days in space and testing the command and service module systems. The next step was to send astronauts to the moon's vicinity without landing. On December 21, 1968, NASA launched Apollo 8, crewed by Frank Borman, James Lovell, and William Anders. The mission successfully orbited the moon, with the crew completing 10 lunar orbits and capturing stunning images of the moon's surface. In March 1969, NASA launched Apollo 9, crewed by James McDivitt, David Scott, and Russell Schweickart, which tested the lunar module in Earth orbit. This was followed by Apollo 10, crewed by Thomas Stafford, John Young, and Eugene Cernan, which tested the lunar module in lunar orbit. Finally, on July 16, 1969, NASA launched Apollo 11, crewed by Neil Armstrong, Edwin Buzz Aldrin, and Michael Collins. The mission successfully landed astronauts on the moon's surface, with Armstrong becoming the first person to set foot on the moon on July 20, 1969. The success of the Apollo 11 mission marked a major milestone in the space race, with the United States achieving its goal of landing a man on the moon before the end of the decade. The Soviet Union, however, continued to pursue its own lunar program, but it was ultimately canceled due to a combination of technical and financial challenges. In the aftermath of Apollo 11, NASA continued to send astronauts to the moon as part of the Apollo program. On November 19, 1969, Apollo 12, crewed by Pete Conrad, Alan Bean, and Richard Gordon, landed on the moon's ocean of storms. This was followed by Apollo 14, crewed by Alan Shepard, Edgar Mitchell, and Stuart Roosa, which landed on the moon's Fra Mauro Highlands in February 1971. The final Apollo mission to land on the moon was Apollo 17, crewed by Eugene Cernan, Harrison Schmitt, and Ronald Evans, which launched on December 7, 1972. The mission marked the end of an era, with Cernan becoming the last person to walk on the moon on December 14, 1972. As the Apollo program came to a close, NASA began to shift its focus towards other areas of space exploration, including the development of the Space Shuttle program and the exploration of the outer planets. The Soviet Union, meanwhile, continued to pursue its own space program with a focus on long-duration spaceflight and space stations. The space race may have been over, but the era of space exploration was only just beginning. The space race, a pivotal moment in human history, sparked unprecedented innovation, pushed the boundaries of exploration, and inspired generations to reach for the stars. The space race may be over, but its legacy continues to propel us forward, a testament to the boundless potential of human ingenuity and collaboration. Thank you for joining me throughout this historical journey. That's all for today's History with Herodotus. Remember to like, share, and subscribe. And until next time, remember that, to understand the present, we must first understand the past.